All right, it's November 18th, 2024. This is part 2 with Noel Coughlin. So welcome back, Noel. However you'd like to go for it.
Hi, Daniel. Thanks for letting me hang out. After watching the last one, I realized I speak pretty quickly, so let's see if I can slow this down a little bit. The long story short of what's happening, right, with science and physics and their quest for the unified field is that they don't think it can be discovered. They don't think it can be discovered because of what's called Heisenberg's principle of uncertainty. And that just states that we can't be certain the momentum of these fundamental particles as well as their position. So let me share screen with you here. Go back to this. And we'll just kind of go through some stuff. Okay. Am I sharing? Cool. I can't see you now, so just if I ask questions, answer verbally. So I kind of wrote a letter to this Sabine Hassenfelder. She's on YouTube a lot, and she's doing a lot of stuff about physics and whatnot, right? So I sent her a few papers. Let's see if I can open this here. Just telling her a little bit about the work on the unified field. And you can imagine she's got 1 million viewers, right? So she's not going to be able to respond or whatever. But I kind of, unless it's a great coincidence, I kind of figured like that she got my letter because 2 days later, she gives this. Come on, you guys. And I just want to show everybody where it is. Now it should start. No, it's going to force me to go through 5 seconds of your thing. Okay. Sorry, you guys. Okay. So I'm just really trying to show that this is her video where she responded to me by saying, see, why our dreams of a final theory might remain just dreams. Now, I posted a comment here, and I don't know whether she took it off, but I never saw it again. And it was just saying that Heisenberg's principle of uncertainty is based on an axiom. And I led her to Andre Macaude's paper. Let's see if I have this. The critical analysis of the origins of Heisenberg's uncertainty principle, where he explains how and why the fallacy or the mistake occurred. I'm going to bounce around a little bit. So anyways, she basically explains why she doesn't think we'll ever discover the unified field, and it's because we don't know how to measure at the quantum level. She says we first have to understand what's going on in a measurement in a quantum mechanics. She adds Einstein's relativity theory with Heisenberg's theory of indeterminacy and its related uncertainty principle, and she explains how there's a fundamental limit to resolution which hampers us from calculating the exact location in time and space of any particle. This becomes the space-time uncertainty, she mentions. So part of the problem she explains on 814 is that we don't know how to measure at the quantum level. Okay, kind of. On this other video, she talks about, do complex numbers exist? She explains if we calculate a prediction for a measurement outcome in quantum mechanics, then the measurement outcome will always be a real number. So it looks like if you can get rid of the complex numbers in quantum mechanics by splitting the equation into a real and imaginary part, and that will never make a difference for the result of the calculation. So in essence, she's saying that the complex numbers do get kind of like translated into regular numbers. In this paper by Macaude, Evolution from the Complex Plane to the Quaternion Coordinate System to the Trispatial Geometry. Here, so I'm going to show one more thing here. So I'm a little discombobulated. It's no big deal. There, let's go there. We're going to do 5 seconds. So, find the paper she mentions here. So she's talking about this paper here, Quantum Physics Needs Complex Numbers by Trillo and Renau and company, okay? She goes in to explain why, and this is similar to how in evolution from the complex plane to the quaternion coordinate system to the trispatial geometry of Andre McCod's paper, he, go down to the bottom, quotes this same paper by Renau and Trillo right here from 2021. Quantum theory based on real numbers can be experimentally falsified. Another paper is ruling out real valued standard formalism of quantum theory. And the third is complex numbers are essential in quantum theory. Experiments reveal. Now, McCod has rectified the problem by explaining how it all works in this paper here. It comes down to the end result of kind of like this. They weren't measuring the correct frequency and the correct amount of energy in the electron about the hydrogen atom in the Bohr model. So what he explains here then is we now observe that when using the correct frequency of the real amount of energy induced in the ground state of the hydrogen atom, the concept of wave group or wave packet was not needed to explain the difference between the presumed but erroneous calculated velocity of the phase wave and that of the particle that it controls, since a calculation with the correct frequency clearly demonstrates that there is no difference in velocity between the momentum energy of the electron and that of the electron itself, and that the phase wave can only move at the same velocity as the particle whose motion it controls, which means that there remains no uncertainty as to the location of the electron with respect to its momentum energy. Now, of course, this is for scientists, dear friends, so they're going to need to study these things if they actually want to learn all of this. But it's easy to explain to the layman in association with, let's say, for instance, right here, he's explaining the total number of magnetic maximum to minimum potential oscillations in the electron. So here is he showing how many times the electron goes from maximum magnetic to minimum magnetic. And I think I'm doing that opposite. But from minimum magnetic to maximum, to minimum to maximum. And so this phase wave that's being created within the oscillating parameters of the electron, we'll just pretend this goes in a big circle, whoosh, like this. Does that make sense? And it goes around the proton's frequency related to the quarks. Okay, we're not going to get into this too much, but you're going to follow me as soon as I'm done. So let's pretend this is the circle of the proton, and this is the circle of the electron. Whoosh. The point being is that because we now have his electromagnetic mechanics equations, which explain this all very clearly, we know that, for instance, if the electron was right here at one time, because we know that it oscillates exactly 18,779 times around the outside of this, we can then, in a certain time period, we can then say, well, if we want to know where it is and we know it's right here, we'll be able to know where it is in a half a second or a second because we now have the correct equations. Long story short about that, let me get back over here and stop sharing so we just hang out. Or you can still see me, I can see. I'll just keep the share screen. So they weren't measuring properly when they didn't take into account Kaufman's data related to the amount of energy in that electron and the hydrogen atom. That led to a bunch of confusion. Why don't I go ahead and read here? Which Andre rectified. Let me open up then his other paper. And I'll close those other two so I don't get slowed down here. Sorry, my eyes are kind of bad. I'm trying my best. Where's it at? I think I passed it already. Oh, here it is. Okay. So from E equals mc squared in the normal space to E equals mc squared in the complex configuration spaces. So this is the last paper of his 700-page thesis. At the end of it here, the end of 750 pages, he kind of clarifies what happened here. So his conclusion to this whole thing is about how his research project has allowed identifying the four major disconnects between the set of premises that underlie the current set of kinematic and electromagnetic mechanics theories and the pool of experimental data which has accumulated over the past centuries. The first disconnect concerns the longstanding belief that Newton's gravitational force is 39 orders of magnitude weaker than the Coulomb force. Okay, he rectifies that in his paper, Unifying All Classical Force Equations. The second disconnect concerns the decision in 1907 by the theoreticians of the time not to take into account the developments with the possibility that emerged from the newly identified and confirmed electromagnetic properties of free-moving electrons that Kaufman experimental data showed. Okay, it was reported at the time and then only talked about in this biography of Einstein's. The paper Demystifying the Lorentz Force Equation by Andre Macquart explains all this real clearly. Now, this third part, the third disconnect then is what we just are going over right now, and that concerns the calculation error inadvertently made by Louis de Broglie in calculating the velocity of the phase waves of the electron on the ground orbit of the Bohr atom back in 1924. See, he had not been informed of the proper referencing in the literature of the fact that Kaufman's data revealed 20 years earlier that any velocity induced in electrons by the Coulomb force, an amount of energy twice that of its momentum energy, is induced in the electron, which caused him to obtain a phase wave velocity only half of that of the particle that it controls, which then was established as an incorrect foundation on which were grounded all subsequent developments of quantum mechanics and quantum theory in general, as analyzed in reference 20, which is his paper, Critical Analysis of Heisenberg's Uncertainty Principle. The fourth disconnect concerned the long-standing and unjustified belief that the electrostatic repulsion between same-sign elementary charged particles has long-range effects as important as electrostatic attraction between opposite signs elementary charged particles, which was unjustifiably considered as disqualifying the Coulomb interaction from being involved in gravitational attraction. And that was analyzed in reference 72, which is Unifying All Classical Force Equations. So these four disconnects are what have created the problem where everybody thinks that there's no unified field. Okay, let me pop out of here. I guess we'll probably just close that. Now, you recall I was just talking about how they think that the complex plane and the Quaternion coordinate system has to be used in order to consider all these different phase translations or phase wave where the movement of the particles bouncing from here to there and seems to be disappearing. So let me open this paper here. So in this paper here and its companion, I explain universe's or nature's coordinate system in the 6-axis metric. I want to open up the other paper too because they go together. Analyzing, it's called Analyzing, here it is, Analyzing Hamiltonian Quaternions. So in this paper, I explain how the Hamiltonian Quaternions are symmetrical to synergetic symmetrical equations, okay? I go through a little bit of stuff, explaining what Hamilton's talking about and how he's translating these imaginary quantities into real quantities related to the X, Y, and Z Cartesian coordinate system and the points upon the sphere. Here, this is what he's doing in his work here. He's right here. I'm sorry. He's created a new sort of algorithm or a new sort of calculus for spherical trigonometry. Okay, that's what he's creating here. So we're thinking about the sphere and the trigonometry associated with it. He talks about the unit vector going from the center of the sphere to any one of the points R upon the surface of the sphere. The Hamilton quaternion looks like this: a+bi+cj+dk. I, j, and k are imaginary numbers related to Hamiltonian geometry. The a, b, c, and d are all real numbers. So the Hamiltonian quaternions of the form a+bi+cj+dk may be translated into the synergetic symmetrical polynomial equations by associating synergetics frequency to the imaginary I, j, and k components of the Hamiltonian quaternion. By associating the imaginary components of the Hamiltonian quaternion with frequency in this way, synergetics is able to use real physical components of structure along with real cubical equations to express first, second, and third power rates of expansion and contraction in association with the total number of real accountable points upon the surface of the various spherical polyhedrons, as well as within the closest point complex of the internally structured isotropic vector matrices volumetric domain. And this volumetric domain is measured in tetrahedral volumes. So I explain a little bit, basically just that I is equal to frequency to the first power, J is equal to frequency to the second power, and K is equal to frequency to the third power. I explain a little bit along the way here. All my papers are available. Anybody wants to email me, I'll just shoot you stuff. It's no big deal. So here I explain the basic synergetic quaternions as translated basic vector and tensor equations. The long story short of it then is these formulas from synergetics calculate exact total numbers of points upon the surface of the sphere or the spherical polyhedron, because spheres don't actually exist. I'll explain that in the next paper. So here's the synergetic symmetrical formulas. So here you've got the Hamiltonian quaternion equals Q equals a+bi+cj+dk. We go in the reversed order here, but you'll notice then if you have, instead of I, you have F. Instead of J, you have F squared. Instead of K, you have F to the third. Same here. Instead of I, J, and K, you have frequency to the second power, and frequency to the third power. And that's related to then how many closest packed unit radius spheres or tensors are in the octahedron, for instance. How many vectors interconnect, or how many kissing points between those spheres, is this number here, and the amount of total tetrahedral volume is here. So you have these symmetrical formulas, and then I mentioned that these symmetrical formulas set the three scales in accord with specific frequencies, and then these allow us to ratio Planck's constant, the gravitational constant, the fine structure constant, and the mass and MeV ratios of the electrons, positrons, protons, and neutrons in whole basic units using basic math and basic geometry. In the next paper that I just pulled open, this 6-axis metric one, so We might read through a lot of this because this kind of will help us understand just nature's coordinate system. So Bucky says on page 31, he says, I'm confident I've discovered nature's coordinate system, and I explained it in Synergetics 1 and 2. He says all physicists need to do is study synergetics to learn how nature designed atoms and combinations of them in pure principle. I explained that my work's helping to prove his thesis, and that to understand my work, you got to study cosmography and synergetics, and feel free to peek through. It's about 700 pages, but I sent 400 to a friend. So to explain very briefly then, the 6-axis metric and the coordinate system that universe uses at every level of structure is very easy to understand. When we closest pack 12 spheres around one, we create the vector equilibrium. That's the cube octahedron with its 12 vertices. By interconnecting the 12 centers of volume of all 12 oppositely oriented vertex spheres, we create a 6-axis metric. On the right here is the vector equilibrium with the sphere in the center, also shown here. The cube's on the left. So here's the vector equilibrium on the left. Its 6 axes then has been interpenetrated with the 3 XYZ axes of the Cartesian coordinate system to show how the 3 axes of the XYZ Cartesian coordinate system sit within the isotropic vector matrix, as well as to show that once you place this XYZ Cartesian coordinate system shown in blue into the metric, you get 3 additional XYZ Cartesian coordinate systems axes activated. Now you see this line right here? We'll call that like the x-axis. And then you see this line right here? We'll call that the y-axis. See this blue one here? That's the z-axis. So whenever you put this XYZ axis into this 12-axis metric, you get 4 sets of XYZ Cartesian coordinate systems orthogonally oriented, or 90 degrees of orientation one to another, axes. But right now, I was just trying to show then this thing here has 12 spheres packed around this one. They've been expanded, and vectors are placed in place of the kissing points to show its structure. Let me go back to the other paper then. So 12 around 1 creates the 6-axis metric as these 6 long axes going from vertex to vertex through the center. I hope that makes it a little bit easier to understand. Okay, so in Synergetics, we use models to make this stuff easier to understand. So I've shown you guys my 6 axes. I've shown you guys the 6-frequency tetrahedron made with clay balls and toothpicks, and that's at the last page of my paper examining string theory. Dan, do you want me to pull that up and you can look at that again?
Sounds good.
Okay, sure, why not? Let me, this. Oh, I don't know what just happened here. I must have done something funny. Let's do date. Okay, good, that's better. Well, that's weird. Did I just... When I closed this, I hit something funny, and I don't know what happened. Let me close this and see if I can open all of my files. Open my downloads. Please open properly. Okay, that looks good. Analyzing inner space. This is my analysis linking string theory to the 6-axis metric of the isotropic vector matrix. At the very end here, I just show that 6 axes. I show the... Let me open it a little bit bigger if I can. So basically, then this whole thing has 336 toothpicks or vectors. Let me read my other paper so you can kind of see and follow along. Small. Okay. So that picture there, remember the chart I showed you? It's got all the numbers, and that shows on column 7 of that chart, with all the numbers associated with all the total spheres in the tetrahedron, it breaks up then into these 336 vectors. There's 84 points, right? And then these includes 216 tetrahedral volumes. And then when we fractionate that, we get the 3-frequency octahedron. And here's the 3-frequency octahedron shown in yellow. This yellow ball here, 1 segment, 2 segment, 3 segment, right? And then goes down to here to the other yellow ball, and that's its face. Goes back to here. So if you truncate and knock off all these blue balls on the corners, you get this octahedron. When you knock off this octahedron's yellow balls, the 6 of them, you get all these green balls as the outside layer of the tetrachedecahedron. If you knock off all of these green balls, you get the cube up on its vertex. Here's one of the vertexes. And this cube is a duotetrahedron. That was an upside down tetrahedron. Here's the top point of the regular tetrahedron. There's one point of it. There's the other point. And the other point's right back here. So it's in fractionating the tetrahedron that we get all these different polyhedrons, which are symmetrically phased and which all hold whole rational units of spheres and vectors and volumes, as opposed to the irrational metric, which we use right now. So I explained that, yada, yada, that's how that all works. I come down here, and this is a fun paper. You guys might want to enjoy reading it. Explain how the other polyhedrons occur by fractionating it. So now I come down to here, and this is kind of the important part of the paper. You guys read this if it interests you, but in section 986.090 to 986.096, Fuller explains the process he went through as he searched for and discovered nature's 4-dimensional coordinate system. So Fuller never completed his research to the point where he had developed all of the symmetrical polynomial equations related to his work. Think about how excited he'd be to know that Hamilton's hypothetical 4-dimensional hypersphere and his related quaternions, which use imaginary numbers to map out the theoretically infinite number of imaginary points upon the surface of the sphere, would be related to the real-world 4-dimensional symmetrical quadrinomial equations of synergetics and their relation to the 4 real dimensional face planes of the tetrahedron. The fact that the symmetrical quadrinomial equations related to synergetics geometry are translatable into the quaternions helps prove what Fuller was explaining regarding the fallacy related to the hypothesis or axiom that there are an infinite number of points upon the surface of the sphere. In Synergetics 1022.10 to 1022.15, he gives a definition of the minimum sphere, which is the tetrahedron. Please read. So these symmetrical quaternion equations help prove his thinking by showing how the total number of points upon the surface of any omnidirectionally expanding or contracting polyhedral sphere are always accountable in whole rational units by using only basic mathematics and basic geometry in association with its frequency. Fuller hadn't discovered the symmetrical trinomial vector equations or the quadrinomial tensor equations related to the Hamiltonian quaternions, but he did discover the binomial equations related to the complex numbers. Notice once again how frequency takes the place of the imaginary component I within the complex number a+bi as it associated within synergetics binomial equations. This occurs in the same way that frequency takes the place of the imaginary components I, j, and k within the synergetics quaternion equations as far as they're related to the Hamiltonian quaternions. So you'll see then that he has these equations in synergetics. 2f to the second plus 2 is equal to the total number of points on the surface of the tetrahedron's externally expanding and contracting tensor field. We'll notice that a plus bi is real similar to, right, a plus b times frequency to the second power takes I. So, and there's the formulas that he found for the other polyhedrons, the octahedron, the icosahedron, the cuboctahedron, and then I revised his for the cube so it's correct. We'll take a brief moment once again to note the significance of these discoveries A plus bi is related to the complex numbers associated with the infinite number of imaginary points upon the surface of the imaginary circular plane. But a plus bf squared equals the total number of real accountable points upon the surface area of polyhedral spherics. bi plus cj plus dk, as I showed in my last paper, is related to the quaternion vector equations, wherein we have an infinite number of directional vectors connecting the center of gravity of the sphere with a theoretically infinite number of points upon the surface of the sphere. Bf plus cf squared plus df third is equal to the total number of real accountable vectors interconnecting real accountable points within all real physically structured polyhedral spherics. A plus bi plus cj plus dk is related to the quaternion equations and the infinite number of imaginary points upon the surface of the hypothetical four-dimensional hypersphere. A plus b times frequency plus c times frequency to the second power plus d times frequency to the third power is equal to the total number of real accountable points upon the surface of the spherical polyhedrons, as well as within their interiorly structured geodesic design. And then they all hold whole rational units of tetrahedral volume. So coincidences like these are universe's way of saying, hey, Earthians, wake up. We notice now how synergetics takes the imaginary infinities out of the equations and replaces these with an exact total number of accountable vectors and tensors in association with the frequency of the various spherical polyhedrons as systems. Down here, then, we'll explain a little bit about that end note. But let me go ahead and read this last part. So proofs must proceed from the minimum whole system to universe, and the differentiation out of universe of the special case conceptual system. Proofs must start from the minimum something, that is the minimum structural system. All geometrical and numerical values derive from fractionation of the whole. See, all geometrical and numerical values in universe So these examples show us an actual mathematical relationship between the face planes of the polyhedrons, which develop as whole rational numbers of point complexes upon the surface of these real spherical polyhedrons, as a ratio of a plus b times frequency to the second power, where f equals the frequency component of the equation of the real polyhedral system. This f relates to how frequently we symmetrically fractionate the system a real number of times. How frequently we fractionate something is equal to how many times we fractionate it. Notice how this differs from the imaginary and therefore misassumed infinite number of points upon the surface of any circular plane as a ratio of a plus bi, where I equals the imaginary vector component of the equation of the imaginary circle. In An Imaginary Tale, Paul J. Nahin states on page 184 that complex numbers represent vectors, that is, quantities with magnitude and direction in the complex plane. This I as the imaginary vector component relates to how we imagine that we can fractionate the system an infinite number of times by creating an infinite number of vectors connecting the center of the circle with its circumference. This I and its association with an infinite number of directional vectors may be related to the Zeno paradox, which hypothesizes that we may continuously fractionate a line into smaller lines by simply splitting it in half. And no matter how many times we fractionate this imaginary line, it will still have exactly half of the length from which it is fractionated, and it will never reach zero. This is the same thinking regarding the infinite number of points upon the surface of a hypothetical circle, or upon the surface area of a hypothetical sphere, or 4D hypersphere. So you see, with the advent of molecular technology, we quickly came to realize that there are no perfect spheres with an infinite number of somethings to act as points upon the sphere. There are always an exact number of point complexes as atoms upon the surface of any real polyhedral atomic spheric structure which universe creates. Take as an example the exact total number of carbon atoms in the carbon-60 molecule with its very spherical truncated icosahedral shape. These new forms of carbon-based molecular structures were so fascinatingly similar to the geodesic domes which Fuller is famous for, that scientists posthumously named this new class of carbon molecule and its series of different sizes after him. These are called fullerenes. See figure 9 on page 17 of my paper, Understanding Relativity Theory, to view a model of the spherical carbon-60 molecule. And for another example of how there are always a total number of atomic points in any molecular structure, see Teo and Sloan's paper, which I mentioned above. Teo and Sloan's paper is right here. Teo and Sloan explain how they're able to use these types of equations to count the total number of electrons in atoms in a range of close-packed high nuclearity metal clusters. They state there are many potential applications of the results presented in this paper. In metal cluster chemistry, the enumeration of the number and disposition of atoms within a cluster may be termed simply as atom counting. In fact, these atom counting results not only provide new insight, but also serve as a vehicle for electron countings of closest packed polygonal or polyhedral metal close cluster systems. All right, let's stop sharing screen for a second here. Where'd I go? Here's the Zoom. We'll chat some more. Let's see here. Cancel share. Oh yeah, it's just us now for a second, right? Let me grab a little copy of that polyhedron I was telling you about. So here's a model of the carbon-60 molecule. Oh, there it is. So see how it's very spherical? It has 60 buckyballs all interconnected in the shape of, and you can just Google, and it'll show you a picture like this for a carbon-60 molecule. And so we know that then this is very spherical, but it's not an infinite number of points. It's exactly 60 points. You could have lots and lots, maybe up to close to, what a person might think about as infinite, because you can have trillions and quadrillions and sextillions, etc., of points upon the surface of a sphere, spherical polyhedron, but there are always going to be an exact total number of somethings, just like we just saw that there's an exact total number of oscillations, magnetic oscillations related to the electron going around the proton. And that's why Heisenberg's uncertainty principle is not a principle, but an axiom, which is now shown to be incorrect, because we're now finding the correct measurement system, and by some miracle, some smart dude named Andre Macquard was able to synthesize a complete system of electromagnetic mechanics equations, showing exactly in accord with regular sciences all their math and all their stuff, how it all works. And if they want to not pay attention, it's their fault, but that's just kind of how this stuff works. Well, I think that was kind of fun. I think, other than questions and stuff, I think that kind of got through some more stuff I was trying to explain. I hope that helps us to understand then how these, what they're talking about, like within the Jacobian matrix math and the unit vector, and how it's used to create space and whatnot, can be then understood within the context of synergetics, since we kind of just proved that synergetics can take the place of the complex numbers and the imaginary components of the quaternions by placing an exact number of somethingnesses always everywhere in relation to wherever these polyhedrons growth patterns are revealing themselves to mankind. And if they're revealing themselves as the polyhedral growth patterns of, subatomic constituent elements, well, that's something we'll need to try and study further on to make more connections. You'll recall from my paper here, I'll share screen again here then. Hang on. We'll just go over very briefly. Okay, sharing screen. So So then once again, we start learning then about these ratios then in association with synergetics geometry. We start thinking about how then the inverse square law develops. Look right here, 1r squared, the inverse square law, is directly related to the inverse square of the fine structure constant. where the inverse square of the defined structure constant, 1 divided by a to the second power, is equal to 18,778.233. Now, that's the total number of magnetic oscillations, which Andre is showing in his paper. He has 18,779. Because I use synergetics as the pre-time precise metric, I was able to take this number, 18,778, right? So the inverse square of the defined structure constant is equal to the c squared in Hartree units, okay? This is the second powering of light speed in Hartree units, which shows us how light speed became embedded within atomic mass when EMR began to hyper-expand at the beginning of universal expansion and its second power rate. So as soon as it went to c squared, it turned into protons and neutrons. Here's the proton MeV and the neutron MeV, and that's equal to that number. And so we have basic number patterns in which then go ahead and show us how this number divided by that angular momentum covariable Planck's constant gives us the gravitational constant. You know, people are interested again, once again, go ahead and study this stuff, you know, but it's here for us, dog. There's stuff for us to study. I guess that's kind of it, unless you got questions or if your live stream folks had questions. Next time, maybe if you want to hook up whenever, we'll go over real basic synergetics. We'll show lots of polyhedrons. We'll talk about frequency and kind of like a basic class without going into all this stuff.
Yeah, that was epic, truly. I'll ask a short question to get a little bit of a bigger view, and then I'll make a few more comments. What is imagination in synergetics? What is imaginary?
Well, Bucky talks about imagination as the image creating center of the mind. And I was going to pull some other papers and show you Einstein, Podolsky, Rosen, where Einstein's talking about if something exists in reality in the concrete world, we should be able to model it and mathematically extrapolate on it. But you see, we don't have those correct. I'm going to go up to the top again. Where is that? I know you're not looking at it, but see, Einstein's pondering why the proton's exactly 1836 times the mass of the electron. Feynman's wondering, you know, why the fine structure constant's almost exactly the inverse of the prime number 137. I think I went off track. What's imagination? Yeah, so what Einstein was talking about was how we should be able to, once again, find the mathematical concepts which lead us to understand how and why all these different number patterns relate. And that's what I feel I've discovered with synergetics. Simplifying and answering these questions. I think that this was a pretty good meet. If you have more questions, go ahead.
Yeah.
Or
Okay,
comments, yeah.
let me give a few connected steps. There's really so much in there. I hope that we can also work on improving like hyperlinking or usage of ontologies or some other way to really trace how these different equations and forms pop up. Here's kind of one place that got me. So the purported need for imaginary coordinates, the complex plane, in quantum is concordant to, in a way that you've described and the citations describe, to the frequency aspect of a synergetics where all things are always an exact total of some things in the real modelable situation. And there are these incrementally constructible frequency shell by shell. Those are the constructible crystal shapes which have in the isotropic pre-frequency, pre-perspective symmetry break. In that space, they have rotational and some other types of symmetries, I'm sure. So it's like where those symmetries in theory and practice intersect with incrementable construction with spheres, close packed, then there's this all integer accounting for vectorial geometry, the syntropic, energetic, synergetic systems. Is that nature's accounting system? Is that what links these? That's an empirical inquiry.
Yeah, and I guess that's what I'm trying to prove, that we have a mathematical and geometrical system which allows us to rationally think about and link all these different number patterns. Remember, all those number patterns I'm showing you are based on the total number of vectors inside of the different polyhedrons. We'll show you again just real quick here. Let's open up, share screen real quick. Hit that, share screen. Sorry, I'm kind of space cadet. Okay. So see, this is the anthropic system, right? It's based on mega electron volts and seconds and meters and grams and all that stuff. And this is a non-anthropic system. It's pre-time, pre-size. It's something that universe discovered, that we discovered from universe, right? It's based solely on the total number of energy vectors and gravity tensors and volumetric domains, which self-stabilize themselves, right? And so these are based on the total number of, so the tetrahedron with 137 spheres to its edge length has exactly 18,768 times 137 touching points. And that's where we're coming up with these different number patterns. See the 918 frequency, which has 919 spheres on its edge length. It has 1836 times 1838 times 92. This is close to the neutron, and this is close to the proton. This is super close to the neutron, and the 3676 frequency tetrahedron has that total number of vectors. So we'll recall, when we take this number, 6760164, and we divide it by the total amount of angular momentum in one circle, 360 degrees, we get this number here. So it's all based on common basic math, as well as understanding of how the total numbers inside of the isotropic vector matrix are related to our regular mathematical system. So the six-axis method is just calculating things in a different manner without any time added, seconds added, and whatnot. There's so much more to go over. So yeah, I could get started again, but
Yeah, I'll make a
I think
comment
we've
on
had
that.
it.
It's this question of what would constitute an anthropic or a non-anthropic measurement paradigm in terms of the coordinative function that SI, CGS, the little yellow cube in the children's classroom, 1 centimeter, composing them into rows of 10 columns, then layers, 10 times 10 times 10, associating the cubic with the edge length, with the calorie, with all of these different units tied together in a way that is multipliable and denotable in base 10. So
Yeah,
it's a massive knot that is one possible co-measurement integrative approach, and every single piece here speaks to these other ways that patterns and descriptions appear, rather than requiring what appear to be these coefficients, fixed coefficients, first, second, third order power relations that in the XYZ cubic have to be finessed, but in synergetic geometry are, again, incrementally constructible, the all integer accounting and all this.
yeah. So I mean, like we talked about before, not that many people are studying synergetics, so I can only imagine what would happen if people set their minds to try and use this system as opposed to the XYZ Cartesian coordinate system. I haven't really tried to think about some of all of that. Our system works so well that once you get through high school and you learn it, you're just like, cool, length times width equals area, and add a height to it, and we get a volume, and we're cool with all that cubic measurement. This just shows once again, and it was this whole process I went through was only done because after I kind of remember what that Arthur Young guy told me. I thought, well, I had some time off in 2009, 2010, just hanging out and enjoying life. And so I got busy with drawing up them charts, and they're all hand drawn. Took a little while, and it took a while to study them and look at them and think about it and study synergetics and understand that he's talking about electromagnetic radiation. Let me explain real quick here something, since we're still just hanging out chat. Let me share screen. Let's look at this, and let's try and think about this picture here, the 6-frequency tetrahedron. Let's pretend that this is not a 6-frequency tetrahedron. Let's just pretend here. Let's look at the bottom edge line. Okay, so this bottom edge line, just pretend it's just one toothpick or one line, okay? Pretend there's nothing in the middle here. It's just an empty tetrahedron. Okay? Pretend that this tetrahedron's edge length is the unit vector, which in synergetics represents the lowercase c in physics. That's how Bucky says it. He's funny. So the vector of synergetics represents the speed of light in physics. Because we're trying to understand electromagnetic radiation and the relation between these polyhedrons and the electromagnetic radiation spectrum in relation to frequency, let's think about how this would be a 1-frequency tetrahedron, okay, with nothing inside of it. Right now it's a 6-frequency tetrahedron, and you can see the intervals 1, 2, 3, 4, 5, 6. The edge length is the same, but we've increased the frequency of the system and compacted it. It's got more dense. You could tell that if I threw that against the wall compared to the empty shell, it would have more force because it's more mass. That's if I threw it at the same speed, because mass times velocity is equal to force. So as this tetrahedron gets more massive or more dense, as I increase the frequency inside of it, but I don't increase the edge length, we can imagine, for instance, how this could become a 1,000,000 frequency or a 10 to the 23rd power frequency with so much stuff inside of it that it would be super dense and weigh a lot. This is kind of the idea behind, let's just say this was a 1-frequency photon. It's only going to have a certain amount of energy associated with it when it slams into something, right? If it's a 2-frequency, it'll have twice as much. If it's a 4-frequency, it'll have 4 times as much. And you can kind of imagine just lots and lots more vector components associated with inside of it. So it's a more compact or dense photon. So we can think about the density of the increased frequency of the electromagnetic radiation wave as a condensed photon of higher and higher frequency, and therefore more and more mass density, which is like what we talked about the other day with how the oxygen atom is the same size as the hydrogen atom at the same temperature and pressure in accord with Avogadro's theorem, but it's got 16 times more stuff in it. It's got 8 protons and 8 neutrons, and the hydrogen's only got 1 proton. So 8 neutrons and 8 protons makes up the 16 atomic mass unit or weight of the oxygen. And just the 1 proton of the hydrogen makes up its 1 AMU, or 1.008, or whatever it is. So we get denser and denser at the, what seems to be, from the research, denser and denser, potentially, at the gaseous level down into the EMR range. Does that make sense, kind of? EMR just keeps getting denser and denser in accord with the frequency. At the molecular and solid range, things get bigger and bigger in accord with the frequency, like we would just see this picture here. And then we say 1 frequency is just this little tetrahedron, and 2 frequency is this bigger tetrahedron, and 3 frequency is this even bigger tetrahedron. And that would relate to like Theo and Sloan's work, where more and more stuff stuck together is higher frequency polyhedral continuum, a bigger and bigger atomic molecular metallic structure. Well, okay, I think we got plenty to talk about next time, but I've had fun.
Yeah, I'll ask a question from live chat. Okay. Stroopy wrote, has Noel considered those numbers of relevancy in a dozenal base before, base 12?
No, but I've heard that before, and I think Bucky goes through those different systems in the back of his book called Numerology, and he shows how the octave system, really the quantum wave, exists. And it's too difficult for me to explain right now, but you'll notice then that. Let me pull up this chart because this might be important since we're talking.
You also had mentioned the color plate in Synergetics and a letter to show.
Mm. We'll go over the color plate, but we won't go over the other. No worries. Let me open this thing up so you can kind of see. I'm not sure that I'm answering Strupi's question, but I'm trying to give us some ideas if this thing will open up. Any other questions for me? Okay, here, so let's do 75%. Computer's going to. Okay, so numbers. What is it? Did it go blank? My computer just went blank.
Just repeat the an error has occurred. Just it's all good now, but it blipped for a second.
Anyways, here, let's see what happens. And I'm just showing how all those total number of vectors, tensors, and volumes, they all reduce to the prime number patterns as I showed you, but they also reduce to, yeah, my computer's not, they reduce into the indig patterns.
Which Bucky associates with sort of classical numerology, finger tallying.
He associates this with quantum mechanics and the on-off start point for the quantum oscillation patterns. It's hard to understand. I haven't really thought about it for a while. So let me just show you, though. The indig of the numbers is a system of 9. Do you see how we have the natural numbers up top? 1, 2, 3, 4, 5, 6, 7, etc., etc. So when an indig is an individual digit. If we take 1 plus 1, we get 2. If we take 1 plus 2, we get 3. And so when we add all the numbers in the natural numbers together, it turns into a system of 9 where 9 becomes 0 as the no stop point. You'll notice the total number of balls in the triangle, the number of balls in the tetrahedron, the volume. They all follow patterns, 1, 4, 1, 2, 8, 2, etc., until it starts again, 1, 4, 1, 2, 8, 2. So no matter how far you go up, all of the total number of vectors, tensors, and volumes all follow this pattern. What's kind of cool about it is just how all the different patterns evolve. And that's why we see that when the 17 and the 23 are revolving around the 137 and the 919, for instance, it's giving us all kinds of different ratios to the atomic nucleus structure.
Thank you. Stroopy wrote, 137 is 11 dozen 5, just 7, i.e. 6 around 1 less than a gross, 144, 12 by 12.
That's cool, yeah. I made all kinds of interesting stuff about that number, but some of it's not as pertinent to our stuff as I'm trying to allocate. Well, I think I had enough. Let's get more questions from him or others.
Yeah, that's perfect. Noel, thank you. Again. We'll coordinate for next time. And
yeah, no rush, no worries. It was good chatting with you.
Thank you for sharing it. Farewell. Bye.
Bye-bye.